When air flows past ports in the venturis, it produces low pressure areas. A hose transmits this low pressure to a diaphragm chamber. This low pressure acts on the diaphragm and opens the secondary throttle. Large capacity V8 engines may use a 4-barrel carburetor of two-stage design, effectively two-stage carburetors combined, with each side supplying 4 of the 8 cylinders. A central moulded plastic fuel bowl and suspended metering system can be incorporated into the design. This gives lower fuel temperatures with more precise fuel metering and closer control over air-fuel ratios. This section examines fuel pumps for carburetted systems. Fuel pumps on carburetted systems can be electrical or mechanical. The mechanical fuel pump for the carburetor system is usually mounted on the cylinder head or the engine block. It has a flexible diaphragm. That's a flexible piece of neoprene rubber separating 2 chambers. This diaphragm is operated by an eccentric on the camshaft. It rotates, making the rocker arm move. This movement is transferred to the diaphragm, pulling it down. That draws fuel into the pumping chamber above the diaphragm. The diaphragm spring moves the diaphragm up, and this forces fuel from the pumping chamber out of the pump and into the carburetor. When the engine needs more fuel, the diaphragm moves through a long stroke to pump a lot of fuel. When less fuel is needed, pressure builds up in the fuel line to the carburetor and in the pumping chamber above the diaphragm. The diaphragm spring can't push the diaphragm up so far, and the pumping stroke is reduced. Some pumps also have a return line to send excess fuel back to the tank. As the fuel circulates, it cools the fuel pump and lines and reduces the chance of vapor locks. Carburetor systems can also use electric fuel pumps. Most of these pumps are located outside the tank, though some are inside the tank. One widely used pump is the diaphragm type. It has an electrical section and a mechanical section. When the ignition is switched on, current magnetizes the solenoid. The magnetic field energizes the armature, which pulls down the diaphragm. This creates an area of low pressure that draws fuel into the pump. Pulling down the diaphragm breaks the circuit and stops the current. The solenoid is no longer an electromagnet. The armature is released, and the diaphragm spring forces up the diaphragm, which forces fuel out of the pump and on its way to the carburetor. This action continues, delivering fuel each time. When the engine needs less fuel, pressure builds up in the fuel lines to the carburetor and reduces how much fuel is delivered.